Bismillahirrahmanirrahim. Assalamualaikum dan selamat sejahtera. Okay, now we continue for the second topic on electromotive force and internal resistance, in Malay, daya gerak elektrik dan rintangan dalam. Hai. Activity 3, we will continue our discussion to distinguish between EMF and potential difference. Remember last topic we learned about open circuit and closed circuit, right? So we will further by doing a very simple activity. So we have to have a battery, two batteries, ammeter, bulb, switch and voltmeter. Again, voltmeter we connect parallel with the battery, and then the switch, the bulb and the ammeter all in series with the battery. Okay, first thing we have to close the open the switch. Okay, we open the switch and we look at the bulb. The bulb will lights off, right? Lights off because there is no current flow. Then the reading is 0 ampere. And the voltmeter reading is 3.0 ampere. Okay. Next, we will switch on the switch. Okay. Now this time, the bulb will lights up, and the ammeter will give the reading. Okay. And the reading is 0.3 ampere, for example. And then we have the reading on the voltmeter will become 2.4 volt. Just now when the switch is off, when the switch is off, the voltmeter reading is 3 volts. So now the voltmeter reading has reduced to 2.4 volt. Okay, first question, what is the EMF of the battery? Remember we learned last time that is the voltmeter reading when the switch is open will give you the EMF of the battery. So it will become 3.0 volt. So what is the potential difference across the bulb when switch S is closed? So 2.4 volts. So it will be dropped. So the potential difference will drops a little bit. Okay. After this, we will learn why. Now, compare the readings of the ammeter when the circuit is open and when the circuit is closed. So the circuit open, no reading. When the circuit closed, there is a reading. Now compare the voltmeter reading when switch S is closed and when switch S is open. So the voltmeter reading when switch S is closed is lower because for open circuit we have 3.0 volt. When closed circuit we have 2.7 volt. Now we talk about charge. We want to move 1 kilo of charge. So what is quantity of energy is supplied to move 1 kilo of charge which flow through a battery? Okay, remember, this is what we call EMF. So the EMF is 3.0 volt. So in order to move 1 kilo of charge from the battery throughout the circuit, we need to supply 3.0 joule of energy. Now, what is the energy transformation which happened at the bulb? So the bulb get electrical energy to light plus heat energy. Okay. Okay, next, what is the quantity of energy emitted by the light bulb for 1 kilo of charge passing through it? So the battery supply 3 joule of energy in order to move 1 kilo of charge around the circuit. And when the charge move through the battery, move to the bulb, so the energy will be emitted, will be transformed from electrical energy to light energy. Now, what is the quantity of energy emitted? So it will the answer we get from the voltmeter reading of the voltmeter. So the answer is 2.4 volt. Now the battery supply 3 volt or 3 joule per coulomb, but the menthol ataupun the light bulb gate receive 2.4 volt or 2.4 joule per coulomb. Suppose it must receive same thing, right? 3 joule, but it only receive 2.4 joule per coulomb. So where is the other 0.6 joule per coulomb? Okay. So we will discuss later on. So 2.4 joule of electrical energy emitted to the bulb for 1 kilo of charge, right? Okay, again, we look back. EMF is 3.0 volt. So the reading of the voltmeter when the circuit is open equals to EMF of the battery. EMF or battery cell is measured in an open circuit when current does not flow. Okay, remember, this is the situation when the switch is on. Sorry, when the switch is off. Okay, so current cannot flow. So the voltmeter reading will give you the reading of the EMF. This is the maximum energy per unit charge which can be supplied by the cell. So the cell can give maximum energy of 3 joule per coulomb or 3 volt to drive the 1 coulomb of charge from the battery throughout the resistance R to back to the negative circuit, the negative terminal of the battery. When the circuit is closed, the reading of the voltmeter is the potential difference between the terminals of the cell. The potential difference is measured in a closed circuit in which the current flows, and this is the energy dissipated per unit charge by the resistor R. Okay, so now when the switch is on, okay, the battery supply energy to move 1 coulomb of charge, so it will receive until it come here at the resistor. Let's say this is a light bulb. Okay, so now this is the energy used by the resistor or the light bulb in order to light up the bulb, right? So the energy from here is used to light up the bulb as a light energy or heat energy. Okay, and it will go back to the negative terminal. Alright, so the energy dissipated per unit charge is used by the resistance R. Okay, so this value is get from the reading of the potential difference between the terminal of the cell. Okay, now look at the difference between the electromotive force E and potential difference V. So the electrical energy given to 1 coulomb of charge flowing in a complete circuit. Okay, so we talk about a big energy, okay, from the battery to move 1 coulomb of charge throughout the whole circuit. Okay, now for the potential difference, the electrical energy that is transformed to other form of energy when 1 coulomb of charge passes through a component in a closed circuit means that when we talk about potential difference, we talk about the energy transformed in the components such as a light bulb or motor, right? So this is what we call potential difference. Okay. So again, electromotive force is used in reference of the source of the electrical energy, that is the battery. In other side, the potential difference is a reference to electrical component in a circuit, such as a light bulb or motor or whatever. Okay, again, another one is DGE is we can get from the voltmeter reading in an open circuit or when the switch is open, while the potential difference is given by the voltmeter reading in the closed circuit, i.e. when switch is closed. Now both have the same unit, that is joule per coulomb or volts or V. Okay, so DGE we talk only the battery. Potential difference must have the electric components such as the menthol or motor or whatever lah. Okay, right. Okay, now further. So we have open circuit, closed circuit. Okay, open circuit is refer to EMF, total work done or total energy by a source in the driving 1 coulomb of charge around a complete circuit, where the potential difference is the work done by a source in driving 1 coulomb of charge between 2 points in the closed circuit. So this is refer to the component, okay, and here refer to the open circuit. Okay. Now, why there is the difference? Now comes to the question, why there is the difference? The battery give you 3 joule per coulomb, but the light bulb only gets 2.4 volt or 2.4 joule per coulomb. So where is the other 0.6 joule per coulomb goes? Now this is due to the what we call internal resistance due to electrolyte in the battery. Okay, so in the battery, there is electrolyte which give you internal resistance, which give you resistance for the charge to move from terminal negative to positive terminal. So resistance against the moving charge. So what is internal resistance? Resistance against the moving charge due to electrolyte in the battery. Right? So we want to move the charge from the negative terminal to positive terminal. In order that they have to pass through the electrolyte and it will need energy. So this energy has been taken and it will change to heat energy. Okay. So what is needed to drive a charge against the internal resistance? Then this causes a drop in potential difference across the cell as the charge flow through it and loss of heat energy in the cell. So the energy that is given, suppose given by the battery 3 joule per coulomb, only 2.4 joule per coulomb is given for the charge to go to the bulb or the resistor, and 0.6 joule per coulomb left here as a heat energy. Okay. Right. Now we explain by using mathematical equation. So now E refer to DGE or EMF, V voltage, I is the current, and R is the small r is the internal resistance. Now we have EMF is the big value, the big energy, the source of energy. So here is supposed to be E. Oh, the current in the cell is the same. So here is I, here is also I. Okay, now we start with the work done in driving 1 coulomb of charge around complete circuit. This is the EMF. Okay, so this is divided into two. One goes to R, another one left behind in battery as a heat energy. Okay, so work done in driving 1 coulomb of charge in the external circuit here. This is 3 volt just now. This is about 2.4 volt. So this one will become 0.6 volt. So this is the work done in driving 1 coulomb of charge in the internal circuit as heat energy. So this work has to do to move against the resistance. So it will change to heat energy or heat. So equation will become E, voltage V, and drop in potential difference. Remember, potential difference, the formula is V equals to IR, and we get the formula E equals to V plus IR. E refer to the DGE, V refer to the potential difference across the resistance R, and IR is the voltage loss due to internal resistance. That is current times internal resistance. So we rearrange. So we substitute V potential difference equals to I a big capital R, IR. This is the external resistance here, plus IR. Okay, and we have the formula E equals to I in the bracket big R plus small r, and this will be the formula you can use in order to calculate EMF. Okay. Okay, this is again the formula. Okay, E equals to V plus IR. E is the total energy in the battery. V is the energy used in the light bulb or resistor, and IR is the energy that lost to heat energy in the battery due to internal resistance. So we arrange, we get this formula. Okay. Alright, so we stop here. I hope you understand. If you have any question, please let me know and I will help you to understand more. Okay, see you on the next lesson. Bye. Assalamualaikum.